Ladies and gentlemen, welcome to our presentation. Our presentation subject is a low-cost soft gripper designed for pick-and-place system. I am the Metin Eren Atalay, Mechatronical Engineer, also the Ardi Bilurdagi, he is the Mechatronical Engineer. This presentation main subjects are soft robotics, design, experiment, evolution, and conclusion. Soft robotic is the specific subfield of the robotics dealing with constructing robots from the highly compliant materials, similar to those found in living organisms. Soft grippers, unlike the conventional mechanic device, are made of the compliant materials and are frankly powered by the compressed air. Interest is on the rise, with growing the demand for more versatile devices that can interact in less structured environments. For example, automated harvesting and packing of fruits and vegetables requires the grippers that can handle the delicate products that would be easily damaged by the typical hard grippers. Soft gripper had one more advice. Like was the soft gripper, this holder are made from the softer materials. It can offer the high transport sensitivity. It can hold objects that are the difficult geometry to handle more easily. It's aimed to reduce deformation of the part to be transported to a minimum. Its projects aim to, as already mentioned, the main purpose of this project is to minimize the deformation of the robots during the transportation of the objects in this project, which we developed against the problems of the traditional gripper. It's not only eliminate the deformation problem, but also you can transport the object regardless of their shape and size, with the help of the soft gripper. The project has important potential in the application of Industry 4.0. Now we tell about the mechanical design and the pneumatical design. Each holder of the soft gripper is produced via casting process. In the manufacture of the gripper, two parts mold are made using a core to ensure the pneumatic movements. RTF2 mold silicon and the catalyze activate the reaction is mixed with ratio before the casting. After the current process, the holder can move and successfully complete the pick-and-place process. During the production of the gripper, despite the possibility of stringing and deformation due to the pressure of the air that allows it to move, the thickness of the surface that touches the part was designed relatively thicker. Material with low elasticity is placed on the surface that touches the part during its manufacture. During the construction of the holder, 5 air sacs were produced in each holder. In order to increase the total air volume, the parts between the air sacs were designed as wide as possible. In addition, when the design, the holder, a curved design, was chosen instead of a flat holder design. In this way, its movements are facilitated. Since the design of the flange is based on the IRB 1660 robot arm, its dimensions are designed according and printed by 3D printer. The pneumatic design is main part of this project. The robot arm, which moves the desired position with the help of the inputs entered the system, receives the signal to close open gripper. The air from the compressor first reaches the solenoid valve. The solenoid valve triggered by the signal from the robot's open. The air outlet ensures that the air reaches the air conditioning system. The air reaches the conditioner is adjusted to calculate the pressure value and descend the gripper and perform the holding process by ensuring the gripper is closed. After the moving object has reached the desired position, the solenoid valve connected to a conditioner closed, with the gripper's opening signal sent by the robot, and the solenoid valve connected to a vacuum module triggered. The compressed air reaches the vacuum module is converted a vacuum effect in this added the incoming air. It can perform the vacuum process between 4 and 6 milliseconds. In this way, this gripper can be opened by the construction the air sacs. When the gripper is opened, the resize the process is completed and the robot arms wait a standby position for the next holding process. The production cost is desired to soft gripper are 867.79 Turkish liras. This given costs were prepared via an effector to be added to the IRB 1660 robot arm. In terms of the cost, it's a very cheap and suitable project for the continuous, as it has no other cost than the project cost. Experimental evaluation. As we can see, we have produced the prototype of this project, and we tested with a small pick-and-place process. Carried out the holding and without any damage in this object. Consolation. Soft grippers and effector designed to compensate the deficiency due to an effector in industrial robots arms was present. The soft grippers make it possible to grasp objects that are difficult to grip, as well as the pick-and-place objects that are likely to be a deformation much more safety. This research contributed to the design of the soft robotics grippers with its low-cost materials and unique mold and core design. Future work includes implementation of non-Newtonian electroviscous fluid into the design in another fluid sacs to successfully mimic human hand movements. Improvement of the material with further additive production methods. Thanks for listening to this presentation.